This is lesson 4.1 in Algebra 1 on solving inequalities. So we did solving equations unit, and we're going to find a lot of the same skills are going to apply when we solve inequalities. So today, you'll be able to graph a linear inequality, write a linear inequality that describes a graph, and then solve linear inequalities involving multiple steps. So those are our three goals for this lesson. So inequalities are statements that are not equal to something, but they are unequal. So there's the word equals in the word inequality. And unequal means they're not equal. So we're looking at ways that two things aren't the same. So one may be larger than the other, or we could say that one is smaller than the other. So you can see here we've got some descriptions and symbols and some examples we'll do. All right, so you know that the description for is equals is just an equal sign. That's all an equal sign is. And then when you graph a solution to an equation or an equality, you just simply put a couple points on a line like this, and I need to graph x equals 3, and so I'm simply going to put a dot on 3, and that's how you graph an equality or an equation, solution to an equation. It's a little different with inequalities. So inequalities, like this first symbol, is kind of like your right hand. Is means greater than, so your right hand's greater. Less is your left hand. Okay, so less is left. Just remember the L's go together. There's another way to say is greater than. You could say is more than or exceeds, and there'll be other terms that we will use eventually in here, but it's important to understand at least those three. And then it's important to understand how to graph. Well, I'm still going to put the same values on the line. I'll put 2, 3, and 4 on there like this. But what you place on this value of 3 in the inequality is going to change based on whether it's greater than, less than, greater than, equal to, or less than equal to. So with greater or less, we always use an open circle. Okay, so you're going to use an open circle on 3 because it's a boundary value, but it's not actually part of the solution. So we mark it with an open circle to indicate 3 is not greater than 3, but anything to the right of that. So I'm going to just test and ask yourself now, so is 2 greater than 3? Well, no, so I'm not going to shade to the left to find the solutions. I'm going to shade to the right because 4 is greater than 3. So anything like 3.11 or 3.00001 is going to be included in the solution, but 3 is not. So 3 is the boundary. So things just slightly larger than 3 is where the solutions begin, and then they go forever out the right side of the number line there. You're going to get numbers that are larger and larger and larger. So then for is less than, you're going to see the same type of thing, except what you're going to have is an open circle. And then is 2 less than 3? Yes, so I'm going to shade numbers to the left because they are less than 3. Now when you look at a greater than or equal to symbol, you're going to use a solid dot on the value in the inequality because it is part of the solution. It's the equal to portion of the solution. But you also have to mark all the things that are greater than. So I've got my 2 and my 3 and my 4, and I'm going to put a dot on 3 because that's where my solutions begin. And then I'm going to shade to the right because 4 is bigger than 3, and all the solutions are the values to the right of 3. And then if I wanted to do this last one down here, I've got a dot that it keeps erasing my dot. I'm going to shade to the left because 2 is less than 3. 2 satisfies this inequality. So anything to the left would satisfy the inequality. Okay? So some things to remember on this again. So if you have a greater than or less than symbol, you just use an open circle on that value. That's the boundary. And if you have an equal to bar, then you're going to use a dot. And then you want to shade the correct side that has the solutions we're looking for. Okay? So you're going to solve linear inequalities just like we solved equations. you're going to mark and label the line with the solution value, but then make sure you put a value to the left and the right as well. And it's important to remember, if you've got -3, what goes to the right and what goes to the left? Is -2 on the left or is -2 on the right? Well, as you move to the right, you're getting larger. And -2 is larger than -3, and then this would be -4 is smaller. So with negatives, you got to be careful. You got to think about those when you put them on there, which way those numbers are going to go. Then you're going to place an open circle or a solid dot. So open circle for greater than or less than, and then a solid dot for equal to. Okay. And then you're going to shade the line toward the values that make the inequality true. Okay. All right, here's example 1. I didn't give you any algebra. There's nothing left to do to solve that. It's simply c is greater than -3, so I'm going to put -3 in the very middle. And I'll put -2, -1 up here, -4, -5 down here. My boundary value is -3. There's no equal to, so I use an open circle. And I want values that are larger than -3. That's to the right. Okay. You try the second one there. Just stop the video and then start it back up when you're finished. All right, I'm going to put -2 in the middle. This is -1 and 0, so this will be -3 and -4. It's an open circle at -2, and then I want values that are less than -2. So -3 is less than. Okay. So example 2, here we got y is less than or equal to 1. So 1's going to go in the middle. That's going to give me a 2, 3 to the right, and a 0, -1 to the left. I'm going to use a solid dot this time. And I'm going to shade values that are less than 1. Less than is left. You try the second one. Start the video when you're finished. Okay. So I'm going to put 4, 5, and 6 on this side, and this would be 3 and 2 on that side. The solution point is 4. It has an equal to, so I'm going to use a solid dot. I want values that are greater than 4, so I'm going to shade to the right. All right. So you write an inequality that describes the graph then. So I'm going to put x down here, and I'm going to put 7 down here, and I'm going to ask myself, did they shade values that were less than or values that were greater than? And they shaded less than. And then I'm going to check the dot to make sure if it's filled in or open. If it's open, I'm not going to put the equal to. If it's filled in, I would put an equal to there. So here's my inequality. This graph is x less than 7. So numbers less than 7. You try the next one. Okay. Hopefully you put your x and your 0 down. They have shaded values to the right that are larger, so that's greater than, and there's a filled in dot, so it's also equal to. Example 4, I've got a filled in dot here, so I've got x and 2, and they have shaded to the right. Right, it means I want values that are greater than 2, and there's a filled in dot. You try the next one. We've got an x and a 5. They have shaded values that are larger than 5, greater than 5. So I'm saying x is greater than 5, but they did not fill in the dot, so I do not put the equal sign. All right, how do you solve linear inequalities? Well, they're just like equations with one difference. When you multiply or divide by a negative number, you must switch the inequality sign. So if it's less than, it's going to become greater than. If it's greater than, it's going to become less than. Now, why is that? So let's look at what happens over here. We're going to fill in the blanks here with either the less than, the greater than, or equal to symbol. So is 10 less, greater, or equal to 3? Well, 10 is greater than 3. Well, is 10 times 2 bigger than 3 times 2? Yeah, that's 20, and that's 6, and 20 is greater than 6. Is 10 times 1 10 greater than 3 times 1, 3. Yes, 10 times 1 is still greater. Is 10 times 0, which is 0, or 3 times 0, which is 0, Oh, is that less or greater? Well, neither. They're equal. Now, what if I multiply by a negative? Notice my numbers have been decreasing. I've gone 2, 1, 0. Now, what happens when I multiply by a negative? I get a negative 10 and a negative 3. Now, which one is greater? Well, because they're negative, the negative 3 is greater. It's less negative. Okay, and 10 times negative 2 is negative 20, and then 3 times negative 2 is negative 6. Well, which one's greater? Well, it would be greater if you had negative 6 than it is to have negative 20. It's a greater debt if you have negative 20. It's less debt if you have negative 6. So we say that the negative 6 is greater, okay, because it's closer to 0, all right, further to the right on the number line. So you notice what happens as you work down this multiplication list right here at 0, the two sides become equal, but then when you multiply by the negative, notice what's happened to our inequality symbol. It is flipped, it is switched around, okay? So, steps to solve, you're going to distribute to remove any parentheses. On each side of the equation, you're just going to combine any terms that are alike. So you're going to look at the left side, combine what's there, no sign changing at all. Look at the right side, combine what's there, no sign changing at all. Then you'll move like terms to the same sides of the equation using the inverse. Then you'll do the opposite operation, starting with addition subtraction, and then you're going to move coefficients using inverse operations. You're going to multiply or divide, and then you're going to ask yourself that critical question right there. Did I multiply or divide by a negative? If so, I'm going to switch my sign. Okay? So, let's solve and graph. Well, I don't have any parentheses. If I look at the left side of the equation, the 2x and the 19 are not, they don't have anything, they're not like terms, right? They're different terms. One's got an x and one doesn't. There's only one term on the right side, so I don't have to do anything there. Now it's time for me to get the like terms together. The 19 belongs with the 33, so I'm going to do the opposite. It's plus 19, so I'm going to subtract 19. So 33 minus 20 would be 13, so this is going to be 14. Just one more, and I still have my 2x. And now I'm going to divide by 2, all very similar to solving equations. I'm going to get 7. You know, look at me putting equal signs down there. I'm so used to it, that's what I do. And did I divide by a negative? No, my 2 was not negative. So this is not negative, so I'm going to leave my inequality sign the same. And then I'm going to graph it. So I'm going to go over here to 7, and I'm going to put an 8 and a 6, 5, 9, and I'm going to put a circle, an open circle. And the x values, it says, are less than 7, so less is to the left. And there's my graph. You guys give the next one a try there. Stop the video, start it back up, see how you did. Well, again, I have no distribution. There's no like terms on the left. I'm going to subtract 13 because it's positive. So that's going to go away like that did. Negative 3 minus 13 is negative 16. Then I'm going to divide by 2. And I get x and then negative 8. And I have to ask myself the question, was this number negative? No, it doesn't matter that the answer came out negative. The question is what you divided by was not negative, okay? You divided by a positive 2, so your inequality sign stays the same. So negative 8 is going to go in the middle. This is less negative, more negative, more negative. Open circle, it says x is greater, so that's to the right. Okay? Example 6, all right. There are no like terms on the left. There's only one term on the right. There's no parentheses. I need to get my negative 8 and my negative 16 together. The opposite of negative 8 is plus 8. That goes away. Negative 16 plus 8. Well, that's 16 bad guys, 8 good guys. The bad guys are winning by 8. Now I'm going to divide. And what am I dividing by? I'm dividing by negative 4. And I'm not going to put any symbol down yet because I'm going to check. Did I just divide by a negative? Yes. Is that negative? Yes. Switch your sign. It's going to go from greater than to less than. Okay, it was a greater than sign. Now that's less than. I'm going to put 2 in the middle, put 3 and 4 on the right, 1 and 0 on the left. Open circle at 2. It says x is less than 2. I want values less than 2. 1 is less than 2, so I'm going to shade that direction. You guys try the next one. All right, hopefully you subtract 40. Negative 2x is greater than negative 2. I'm dividing by negative 2, and I get an x, and I get a 1, and I ask myself the critical question, negative? Yes. We're switching that. X is greater than 1 is my answer. 1, 2, and 3, 0, negative 1. Open circle. X is greater than's to the right. And there's my answer. Okay, here's a little more difficult one. It's just stepping up the difficulty. No like terms left or right, no parentheses, but I've got a 5n and a 6n. I'm going to move the smaller one. I'm going to move my 5n by subtracting 5n. 6n minus 5n is 1n. Then I'm going to add 9 to both sides, and I get n. I get this. I did not divide at all, did I? So my inequality sign does not change, but I think you're going to struggle with n on the right side. I think what you need to do is probably flip this entire thing around. Now notice this says the 14 is greater. The mouth is eating the larger number. So this mouth is eating the 14. So I think that symbol needs to eat the 14. It needs to flip as well. So what I've done is I've spun the entire thing around to say instead of 14 is greater than, and now it says n is less than 14. Okay, those really are the same thing. If 14 is greater, then n is less than. Okay? So that's going to help you graph. Because then when you go to graph this thing, you're going to do open circle and you're going to shade to the left. Because n is less than 14. So 13 is less than 14. 14 is greater than 13. So you gotta be careful with the ones like that. You guys try the next one there. All right, again, I like to move the smaller r. If you want, you can always move the 3r to this side. Like you could do 3r like this, minus 3r from both sides. Okay, if you want to do that. That way you get your variable on the left automatically. So negative 8r, negative 3r, that's like 8 bad guys, 3 bad guys, that's 11 bad guys. Okay, and then subtract the 6. And then divide by negative 11. Well, now I divided by a negative, so I switch my sign around. Okay. Now, if you wanted to do it the way I did this other one, let's see that. So we're going to add 8r. So 6 is greater than 11r plus 3, and then I'll minus 3. And 3 is greater than 11r, and divide by 11. And you get 3/11 is greater than r. Or r is less than 3/11, which is what we got before. So these are both correct solutions. It's just which one's going to be easier for you to graph. So you just need to ask yourself which values left or right on the number line are less than 3/11, that kind of thing, okay? Whoa, we're really stepping up here. So we've got distribution going on. So let's do that first, right? So I'm just going to copy down my 9. And so I've been boxing this in to kind of give you guys an idea what's going on with the distribution. I think I'll do that again. So we're distributing a positive 3. So if you remember, we want to try and check the sign, then what's the value, and then the variable. Okay, so we got sign, positive times a negative. It's negative. 3 times 3 is 9, and there's a t. Positive times positive, that's a positive. 3 times 10, that's 30. No variable. And I'm just going to copy down this other side. Now on the left side, 9 and 30 are alike. That makes 39. There's no opposite operations here. You just combine them. They're both positive, both good guys. Okay, and then just bring down the negative 9t. And on this side, I've got 8 and negative 4. Well, that's positive 4. 8 good guys, 4 bad guys. Good guys win that. Now, which one do you want to move, the negative 9t or the 6t? Well, I'm going to move the negative 9t. I'm going to add 9t to both sides. Now, 39 is less than or equal to 6 good guys, 9 good guys, that's 15 good guys. Now I'm going to subtract 4 from both sides. That's 35. And then divide. And I can reduce 35 and 15. What do you know that divides into those? Well, 7 goes, or 5 goes into those. So it goes in 7 times and 3 times. So there's one way to write my answer. Or I can completely flip it around, and the t, notice the mouth's eating the t, right? So I'm going to flip this around so the mouth is still eating the t. Okay, so either one of these is the correct way to express the solutions there, okay? You guys try the next one and see how you did. I'm going to box this in again. I'm distributing a negative 5. I'm going to keep my 3f the same. That's negative 5f plus 50. These two are alike. They make negative 2f. Negative 6x and f and negative 6f make negative 12f. I'm going to add 12f. And I get 10f. I'm going to subtract 50. I put a t. Negative 49. And I'm going to divide by 10. I'm going to divide by 10. Am I dividing by a negative here? No. So I don't need to switch my sign at all. I'm just going to leave f greater than negative 49 tenths. If you wanted to switch that to a decimal, you could. That comes out nice. It's negative 4.9 if you want to divide that. But I don't know why students are reluctant to leave fractional answers. There's nothing wrong with those. You could also write as a mixed number, negative 4 and 9 tenths, like that. So these are all acceptable. Hopefully you got one of those. Okay, so you can work on Delta Math. There's Skill 4.1 you can start with if you choose, or you can go ahead on to the next lesson, and then you'll be able to do 4.1 and 4.2, both of those skills.